How's it going, ladies and gentlemen? Mr. Donahue here, once again taking a look at 20.1 and 2 redox reactions and balancing them. In this unit, this topic, we're going to get into batteries and voltaic cells and how they all work. And behind all of it is redox reactions. So we're going to be taking a look at them. So our objectives are to determine the oxidation number of various atoms in a compound, identify what has been oxidized and reduced in a chemical reaction, and identify oxidizing or reducing agents, and balance by using the half reaction method in acidic as well as basic solutions. It's a lot, but totally doable. You guys got this. All right. What are redox reactions? Let's start there. Well, they're reactions where reduction and oxidation occur. So redox. Cool. So oxidation and reduction. Remember that oxidation is going to be losing electrons and becomes more positive, and reduction is gaining electrons, becomes more negative. You're going to hear that like 3 more times. All right, oil rig. Can you remember oil rig? See, oxidation is losing electrons. That's where that oil is, right? The charge becomes more positive because you're getting rid of negatively charged electrons. So losing an electron means it becomes more positive. Right, so sodium atom loses an electron, it becomes a sodium ion with a +1 charge. Reduction is gaining. That's the rig part. So you remember oil rig. Oxidation is losing electrons, reduction is gaining electrons. The charge becomes more negative because it's gaining a negatively charged electron. The charge is what's being reduced. So oxidation, reduction, they're talking about the charge. The charge is being reduced. So it gains an electron, which is a negatively charged particle, giving the chloride ion with a -1 charge. So how do we know if it's a redox reaction? Well, you got to keep track of the oxidation states. And if you don't know how to do this, there's going to be a whole separate video for that because you've seen it before and you'll see it again right now, but not for this video. All right, look at the reactants and then the products. Did the oxidation states change? If so, then you have a redox reaction. If they stay the same, it's not a redox reaction. So, is it a redox reaction? Well, let's take a look. I'm looking at this reaction. So I always start with the more electronegative atom, and I have chlorine, so I know each chlorine is -1. And if I got 2 of them, that tells me I got -2 charge overall, which means I need a +2 because this compound has to be neutral. So barium has a +2 here. I'm going to do the same thing here. I know SO4 as a whole has to have a -2 charge because it's a sulfate ion. Each oxygen is -2. That means I got a -8 from those 4 oxygens. And I need a +6 to give me my -2 overall. So sulfur is 6. And if overall I got -2 from the sulfate, I need +2 from 2 sodiums. So each sodium is +1. And then I do the same thing over here. All right. Each oxygen is -2. Sulfur is going to have to be +6 so that overall the sulfate ion gives me a -2. And the barium, therefore, has to have a +2 charge. The chloride ion is going to be -1, and the sodium ion is going to be +1. Now, did any, not +1. So did any of these oxidation states change? Well, let's see. I got sodium +1, +1. I got chloride -1, -1. I got sulfur 6, oxygen -2, oxygen -2. Nothing changed. So no, this is not a redox reaction. This is what we call a double displacement reaction. What about this one? Well, zinc, if it's by itself, has to have a charge of 0. Chloride is going to be -1, which means the hydrogen's got to be +1. And over here, chloride is going to be -1. Which means if I got 2 of them, I have -2 overall. I need a +2. Zinc has to be +2. And hydrogen, just by itself, even though it's a Brinkelhoff, it's a diatomic molecule, it's still just hydrogen, has a charge of 0. So did we have a change in charge? Well, let's see. I had zinc at 0, and zinc now has a +2 charge. That's a redox reaction. All right, and the only way that zinc could have gone up in charge is if something went down in charge. And if you take a look at the hydrogens, it went from +1 to 0. So we definitely have a redox reaction here. All right, some vocab. The oxidizing agent is the substance that causes oxidation to occur in another substance. So the agent is like saying what it causes, right? So it causes something to be oxidized by taking an electron from that other substance. This means the oxidizing agent gets reduced because the oxidizing agent is taking an electron from another substance. So it's gaining one. It's being reduced. The reducing agent is a substance that causes reduction to occur. It causes reduction. It does that by giving an electron to another substance. It's giving it to another substance, so it is losing an electron. So the reducing agent is the thing that gets oxidized. So if we take a look here, sodium is going to lose its electron and force it to be given to the chlorine. So because sodium causes reduction, we call it the reducing agent, and it gets oxidized. And chlorine, you can think of it, it stole an electron from sodium, so it is the oxidizing agent. It causes oxidation to occur. Cool. So what is the oxidizing agent for these ones? Well, let's redo the numbers. Zinc by itself, 0, hydrogen plus 1, chlorine minus 1, plus 2, minus 1, and 0. So the oxidant or the oxidizing agent is the thing that gets reduced. It causes oxidation by being reduced. So I'm going to have to say that's got to be the H+. H+ gets reduced, it causes zinc to be oxidized. All right, well, what about the reductant or the reducing agent? It's the thing that gets oxidized. It causes reduction by giving electrons to another substance. Well, that's going to be my zinc 0. Is it important that I put the charge? Yeah. If I put Zn plus 2, no, that's not the stuff that causes reduction. That's the thing that already caused it. It's the after. So what is the reductant, the thing that causes reduction? Yeah. It's a zinc 0. Okay. And then we also have this thing called a spectator ion, which is going to be the chloride ion, because it is -1 before and it is -1 after. So it is just watching this reaction. It's not actually involved in any of the reaction. All right, so balancing redox equations. Reduction can only occur if there's oxidation. So these two processes are paired together. They're forever entwined. You can't gain electrons unless they were lost somewhere first. Okay, so although they will always happen together, we're going to look at them separately because it's going to be helpful to do so. All right, so we have these things called half reactions. And guess what? If you got a redox reaction, half of it, redox, is reduction and half of it is oxidation. All right, so oxidation is losing electrons. So we're going to look at just that process first. Electrons will be on the product side because you're separating that atom from its electron or electrons. You're never going to see Na0 minus 1 electron equals or goes to Na plus 1. You're not going to do that. We don't like minus signs because we're not subtracting anything. We're just separating it. So how do we show that in an equation? We put it on the product side. That's oxidation. Reduction is gaining electrons, so we're combining things. So we start with two separate things, we end up with one thing. So electrons will be on the reactant side. It'll look something like this. 10 plus 2 electrons will give you 10, 0. All right, so electrons on the left for reduction, oxidation, electrons on the right. All right, balancing half reactions. This isn't so bad because you just always follow these steps and you always get the answer. You just always follow the same process, so it's pretty nice. I kind of like these problems. So the first thing that we're going to do is we're going to take our reaction and we're going to have to split it into two half reactions. Then we're going to balance the half reactions, and the way we're going to do that is first we're going to balance every element that isn't hydrogen or oxygen. Then we're going to balance oxygen by adding water, and we're going to balance hydrogen then by adding H+ ions, and then we're going to balance charge by adding electrons. Okay, so first step, split it into half reactions. I'm going to look at just the copper first. I see that it starts as copper 0 and it ends up as copper plus 2. So I'm starting with this. Next, I got to balance this half reaction. So I got to first balance elements except H and O, and I only got copper, and there's one on each side, so I got nothing to do there. Now I got to balance oxygens by adding H2O. Well, there aren't any on either side, so I got nothing to do in this step either. Third step, I got to balance hydrogens by adding H+. Same deal. I don't have any hydrogens, 0 on both sides, nothing to do. So the last thing I got to do is balance the charge by adding electrons. Now remember, electrons have a negative charge. Well, on this side, I have a charge of 0, and on the product side, I have a charge of +2. So how can I balance these out? Well, I'm going to have to add electrons onto the right side because they're negative and it's got to bring down that positive charge. How many am I going to need to add? 2, because the difference between charge is 2. So this is what I'm going to get. Cu0, arrow, Cu plus 2 electrons. I got a balanced half reaction. Piece of cake. All right, so let's take a look at the other half. All right, so now I'm going to look at what's going on with this nitrate ion. I got NO3 minus, and it ends up as NO2 with an overall charge of 0. Interesting. So I split it into the other half, and I'm looking at it. So now I got to balance half reactions. So first, I got to balance elements except hydrogen and oxygen. So nitrogen, I got 1 on each side. I got nothing to do there. I'm done with that. Next, I got to balance oxygens by adding water where I need it. So I have 3 oxygens on the left and 2 oxygens on the right. So I'm going to have to add a water molecule on the right to get that extra oxygen. So it's going to look something like this. So now I fixed oxygen, but I messed up the hydrogen because now I got 2 hydrogen on the right side and I got none on the left side. So how am I going to fix that? I'm going to add H plus to the side that I need it. So I need them on the left side here. So I'm going to add 2 H pluses so that the hydrogens balance out. I got 2 H's, I got 2 H's, I got O, I got O. So now the last thing I got to look at is the charge. Well, I have a minus 1 here and I got 2 pluses here. So I got a charge of plus 1 on the left side and got a charge of 0 on the right side. So that tells me I'm going to have to add 1 electron to the left side. And this is what I end up with. This is my balanced half reaction right here. Let's check. 1 nitrogen, 1 nitrogen, 2 hydrogens, 2 hydrogens, 1, 2, 3 oxygens, 3 oxygens. Charges, minus 1 plus 2 minus 1 is 0, and 0. So everything is good. Piece of cake. So you may be asking, why are we adding H2O and H pluses? Like, where are they coming from? We're just making this up? No, we're not just making it up, okay? These are complicated reactions that are occurring in solution. So that means they're aqueous. They're surrounded by water, and water is also going to interact with this process. So where did the H plus come from? It came from the water. It was in the water. Where did the O come from? It was in the water. So yeah, that's why we're doing that. Okay, so let's try an uglier one, shall we? So let me split it up. So I see this, I got chromate becoming this stuff, and I got chlorine. Here, I'll do this. Chlorine becoming chlorine gas, right? So I see where I can split this up into 2 reactions. I'm going to put Cl minus, which is what I start with here, giving me chlorine gas over here. And now I need to balance it. So balance things that are not oxygen. Done. Right? Oh, I lied. It's not done. I had 2 chlorines on the right, but only 1 on the left, so I got to times the left side by 2, so it gives me 2 chlorines. I got to double the left side. So now everything that's not oxygen or hydrogen, balanced. Next, balance oxygen. Well, there aren't any on either side, so I don't got to do anything. Same thing with hydrogen. Now I got to worry about charge. Well, I have 2 minuses on the left side and 0 on the right. So that tells me I need to add more minuses on the right side. So I'm going to have to add 2 electrons on the right side, which tells me that this is the oxidation half reaction, right? I'm losing electrons. All right, so let's take a look at the other half. Well, I start with Cr2O7 minus 2, and I end up with just Cr plus 3. The oxygens disappeared on me. I have the wrong amount of chromiums. I don't know what's going on. So next thing I got to do is I got to start balancing. So I look at not O and H, which means I got chromium. So I got 2 on the left side and only 1 on the right side, so I got to double it. So I put 2 on the right side, so I got 2 chromium ions, and I got 2 in this molecule over there. All right, next thing, balance oxygen. Well, I got 7 oxygens on the left side, and I got 0 on the right side. So I'm going to have to add 7 waters because I get 1 oxygen for each water. So I add 7 water molecules onto the right side. Now my oxygens are balanced, but I messed up my hydrogens. Because now I got 7 times 2 hydrogens. I got 14 hydrogens on the right side and none on the left. So how do I balance hydrogens? I add H+. So I'm going to add 14 H pluses onto the left side. Boom. So now I balanced everything except the charge. So now I got to look at the charge. I got a minus 2 and 14 pluses. And on the right side, I got 2 plus 3, so I got a plus 6. So I got a positive 12 charge on the left side and a positive 6 charge on the right. So how am I going to balance this? Well, I need to bring this charge down by adding 6 electrons so that the charges balance out. So now I got to erase all this stuff that I wrote in the way because there it is. So now my charges are balanced. I got 6 electrons, 14 H pluses, and a minus 2 from the chromate ion. That gives me a plus 6 charge overall, and I got a plus 6 charge on the right side. So charges are balanced. Cool. Why are we doing this? Why am I bothering to balance all these half reactions? We're trying to balance the oxidation half reaction with the reduction half reaction. The electrons lost got to be gained somewhere else. So we got to figure out, well, this process happens, how many electrons are lost. With this process, how many electrons are gained each time. So we got to take both half reactions and figure out how we get the electrons lost to equal the electrons gained by multiplying these half reactions till we get electrons lost equal electrons gained. So let's take a look. These are our 2 balanced half reactions. So I got 2 chloride ions giving me chlorine gas and 2 electrons, and then the second equation, right? This is what we're looking at now. We got to look at the electrons lost and the electrons gained. So how do I get the electrons lost, which is going to be this 2, to equal the electrons gained? All right, this one's kind of straightforward. We're going to have to multiply that top one by 3 so that we end up with 6 electrons being lost. So what do we get? We get 6 because 2 times 3 is 6 chloride ions, gives me 3 chlorine molecules and 6 electrons. And I didn't have to do anything to my other equation because now they're equal. So now, in this process, if 6 electrons are being lost and 6 electrons are being gained, we can cancel them out and now add everything else together and get one combined chemical equation. Like this, right? And I can't simplify it anymore, so I'm done. Well, almost. That's a great example of an acidic solution because we got these H pluses, but sometimes they'll ask you, hey, what if this reaction occurs in a basic solution? What would it be? This is a problem because H plus doesn't really exist in any great quantities in basic pHs. So we're going to have to get rid of those. So add the following steps if you're balancing for a basic solution. You're going to neutralize the H pluses by adding OH minus to both sides. You got to add it to both sides so it stays balanced. But what's going to happen is the OH minus on the side with the H pluses is going to neutralize and you're going to make water. So you got to make sure now that you cancel out any H2O you've created. So in a basic solution, if this was our final thing that we got and went, oh, okay, 1 more or 2 more steps to do. I got to cancel out these H pluses. How am I going to do that? I'm going to add 14 OH minuses to both sides. So add those. Now what's going to happen is the OH minus and the H plus are going to combine to give us water. How many waters? 14. So now I end up with 14 waters on the left side and 14 OHs on the right side. But hey, wait a minute. I got H2O on both sides of this equation. So I can cancel some of these out. I got 7 on the right and 14 on the left, so I can cancel out 7 of the 14 on the left, and I end up with this. Notice that now I have OH minus and no H pluses, which is what you would anticipate in a basic solution. Okay, so that's it. So to summarize, split into 2 half reactions, balance half reactions by doing everything except H and O, then doing O by adding H2O, do H by adding H plus, balance the charges with electrons, set the electrons lost equal to the electrons gained, and combine the half reactions. If you got a basic solution, add OH minus to both sides to neutralize the H pluses, making water, and then make sure you cancel out any water that you can. I have a stupid little thing that I do. Once I have a half reaction, I do something, I write this out. I do not O, and then I do O electron. So everything that's not OH, I balance first, then I balance oxygen, then I balance hydrogen, and then I balance charge. And that's it. Just follow the system. Can't go wrong. All right. So I hope you found that helpful. I'll see you in class. I got a bonus example. You don't got to watch it, but if you want to see it done one more time, I'm going to do it again. Okay. Bonus example. this is my reaction. First thing I'm going to do is split it in half. So I'm going to look at this. So I'm going to go, all right, well, I got Cn minus giving me CnO minus. So now I got to balance it. First thing, I'm going to go, oh yeah, I got to do everything that's not OH first, then O, then H, then electrons. So everything that's not O, C, and N, that's balanced, so check. Now I got to balance O's by adding water. So I'm going to have to add H2O onto this side because I got one on that side. So now I've done that. What's next? H's. Well, I just added two H's on this side, so I got to add two H pluses onto this side. Done. I got a balanced charge. Well, I got a -1 over here, and I have a +1 over here. So how am I going to balance that? How did I get +1? Well, I got two pluses and one minus. So if I got to balance this in charge, I'm going to have to add two electrons onto this side. So now that my charge is -1 overall on that side. So this is my first half reaction. And I can tell that since electrons are lost, that this is the oxidation half reaction. So my other one's going to have to be my reduction. So I start with MnO4 minus, and I make MnO2, right here and right here. So now I got to balance everything that's not oxygen or hydrogen, and that's done already. Mn, one on each side. Balance the oxygens by adding water. So I see that there's only two on this side, but there's four on that side, so I got to add 2H2O onto the right side. And now I got to balance my hydrogens by adding them as H pluses. Well, I got 2 times 2, so I got to get 4 H pluses. And now I got to look at my charge, right? I did the oxygens, I did the hydrogens, now I'm left with just my charge. Well, I got +4 and a -1, so I got +3 on the left side. I got 0 and 0 on the right side. So how do I get them to equal? Well, I'm going to have to add 3 electrons to the more positive side. So 3 electrons plus 4 H pluses plus MnO4 minus gives me MnO2 and 2H2O. Cool. So I've done all that. I got my balanced half reactions. Now what? Well, now I got to set the electrons lost, which is 2, equal to the electrons gained, which is 3. Well, I can't get 3 by counting by 2s, and I can't get to 2 by counting by 3s, but I can get them both to 6. So I'm going to have to multiply the top one by 3. So let me do that. I'm going to get 3H2O plus 3Cn minus plus 3CnO minus plus 6H2O, because 2 times 3 is that, and 6 electrons. Now to get the 6 electrons on the bottom, I got to times everything by 2. So I end up with 2 times 3, or 6 electrons. I'm going to end up with 8 H pluses. I'm going to end up with 2 MnO4 minuses, 2 MnO2s, and 4 H2Os. So now I can add all these together. The electrons are going to cancel out. And I'm going to get, let's see, oh, what else cancels out? I got 4 H2O here, and I got 3 H2O here. So I can cancel out 3 of these H2O, and then end up with just 1 H2O there. Is there anything else? Yeah, I got 6 H pluses up here, and I got 8 H pluses over there, so I can cancel out these H pluses. What do I do? You can cancel out those H pluses and 6 of these 8, so I'm left with 2 H pluses there. And now I think I've canceled out everything I can, so I'm going to end up with 2H plus 2 MnO4 minus plus 3Cn minus arrow 3CnO minus and 2 MnO2 and an H2O. And I can check real quick. All right, I got 2 H's, 2 H's. All right, I got 2 MNs, I got 2 MNs. I got 3 C's, I got 3 C's. I got 3 N's, I got 3 N's. And I have 2 times 4, 8 oxygen, and I have 3 times 1, so I got 3 plus 4 plus 1, so I get 8 oxygen. Everything is balanced. Cool. Now, what if this problem said, hey, no, what if it was in a basic solution? Now I got to do those additional 2 steps. Well, I got 2 H pluses I got to cancel out, so I got to add 2 OH minuses to both sides. This is going to become now 2 waters, 2 H2O. And I'm going to go, hey, wait a minute, there's an H2O over here. So I can cancel out one of those H2O and erase it on this side. And I'm going to get rid of the things I crossed out. And I'm going to make this a nice, neat one. I'm going to rewrite this here, H2O, plus that, and the other thing. And I'm going to actually write these nice and neat over here. And that is if it was a basic solution. So I hope you found the bonus example helpful. Bring questions. I'll see you in class. All right. Okay, bye.